Today we are going to discuss conservative and non-conservative forces. What are conservative forces and what are non-conservative forces? What is their importance? And if we have an expression for force, in that case, how we decide whether it is the expression for conservative force or it is an expression for non-conservative force. And we'll also discuss some numericals based on this conservative and non-conservative forces there. Conservative force. Conservative force is one work done by which does not depend upon the path but depends only on initial and final positions. You take a conservative force. The conservative force, if you consider and we consider the work done by which, then it will depend not on the path but it will depend only on initial and final positions. And the examples of this one is gravitational force, electrostatic force, spring force, etc. Now, what does it mean? Like suppose we consider a body which is at this particular point, and we are moving the body from this point to this one. So if this is your suppose point 1 and this is your point 2, so we can move it like this. Here, if you consider the work done in this is W1, if you consider any other path like this one, this is suppose here it is W2. And if I take the body, we move it and then we bring it like this. This is suppose W3. If it is a conservative force, then work done will not depend upon the path. It will only depend upon initial and final position. So whether it is your first case, second case or third, in all the three, initial and final is same. So in this case, the work done will be W1, W2 and W3, all will be equal. Let's take one example, like we have taken the gravitational force to be a conservative force. Here, suppose I have a body of mass m and this is at point A, and we lift this body to the point B, which is at a height suppose h. So when the body is moved up to this point B, now where is the weight? Weight is acting vertically downward there. So mg will be acting downward. Mg is in this direction. H is upward. So work done by gravitational force, this will be equals to mg into h into the angle. If you consider it is your cos 180 degree there, so cos 180 degree, and that will be your minus mgh. This is the work done by gravity. So here from A to B it will take the work done as minus mgh. Let's take another case. Suppose this body is moved from this point and we move it to point C, which is at a distance capital H, or it is at a height capital H, and from there we are bringing it back there to this point. So this is point A and this is your C. Now and this is suppose the one which we have moved downward. So work done by gravity or by gravitational force from A to C, this will be how much? It will be your minus mg capital H. But now when it is coming from C to B, in that case force and the displacement both are in the same direction. So work done by gravitational force from C to B, this will be your mg. And what is this distance? This is your capital H minus small h. So this will be capital H minus small h. So now what is the total work done? So total work done, that means it is moved from point A to C and it is brought back to B. This will be minus mg capital H plus mg capital H minus small h. Now you can see this minus mgh and this minus mg capital H will get cancelled and you will get minus mgh. So now you can see when we have moved from point A to B, the work done was your minus mgh. Here also when we have moved from point A to C and then we have brought it here, again the work done is your minus mgh. Or suppose if I take that this body is moved along a path like this. So, or say from point A to C, we have moved like this one. So again for this particular case also, if you take work done against gravity or work done by gravity, here the net displacement is your h. So gravitational force is downward, net displacement is your h. So work done will be your minus mgh once again. So in that case, in all different cases, we get the work done to be same. And why it is so? Because this force, that is the gravitational force, is a conservative force. One more thing you can see. If you consider that the body of mass m has been moved from point A, it is moved to point B, which is at a height h, and after that we are bringing it back. So in this case, if you consider work done in moving it from A to B, that will be your minus mgh, and work done when we are moving it from B to A, it is your mgh, that is the plus. So the total work done, this will be equals to how much? It will be minus mgh plus mgh, and that is 0. And now why you are getting that? Because here you can see that initial and final positions are same. So net work done will be 0 because it depends upon the initial and final position. If the initial and final positions are same, that means it is just like a closed path. So in that case, work done will be 0. So two things you should remember there for conservative forces. One is that work done does not depend upon the path along which it is carried out. Secondly, it depends only on initial and final position there. Of course, it's one more inference we can draw, that the total work done in a closed path will be 0. So this is for conservative force. Because here, if you just imagine that we want to find work done in the closed path, will the work done in the closed path will always be 0? Suppose we want to find work done in a closed path. Like here, for gravitational force, we have seen that it is 0 if the initial and final positions are same. Here, suppose you have a body of mass m on which we are applying certain force and it is moving along this surface. This has got friction. So if friction is there, in that case the frictional force will act in this direction. And suppose we are moving this body from this point to a distance s. So from this to this, if we have moved, work done by friction. If you consider, so work done by friction, this will be equals to how much? The frictional force, suppose if I represent it as your F, small f, it is in this direction, displacement we have shown in the other direction. So this into minus s, it is your minus fs when it is being moved from A to B. So when it is being moved from A to B, this is your minus fs. And now we are moving this one again from B to A. When you are moving it from B to A, the frictional force will act in which direction? Again, opposite direction to its motion. So in that case, work done by friction when the movement is from B to A, again it is your F into minus S, because S will be now in this direction and F will be in the opposite direction there. So it is minus Fs. Total work done. Work done. This will be minus Fs plus minus Fs, which is minus 2Fs. Now you can see it has started from point A, has gone to B and has come back to A. But so that means it is a closed path. But the work done is not 0. In previous case, we have taken the work done to be 0. This is because total work done in a closed path will be 0 only for conservative force. This friction is a non-conservative force. So let's take now non-conservative force. So non-conservative force. Non-conservative force is one work done by which depends upon path and not on initial and final positions. And its example, you can take frictional force or any non-central force. Okay, so they will be your non-conservative force. So frictional example we have seen, that work done by which it depends upon the path and not only on the initial and final positions there. So this is your non-conservative force. So main distinction between the conservative and non-conservative, you can find that conservative will be depending only on the initial and final position, that is the work done by the forces, and not on the path. Whereas in non-conservative forces, work done will depend upon the path and not on the initial and final position. In closed path, work done by conservative force will be 0. Whereas in non-conservative force, work done will not be 0 in a closed path. There will be some net work done there. So we have done definition of conservative force, non-conservative force, and its importance. Like when we'll have the work done in a closed path 0, when it will not be 0. Also we have done that what are the examples of the conservative and non-conservative forces. If any particular example is given, that you have to find work done by this force, say work done by gravitational force, if you have to find. And once you know that it is a conservative force, you can easily take that the work done will be depending only on initial and final position. But suppose if any expression for force is given, it is not specified what type of force it is. Like if it is, you have to prove that work done by this gravitational force from this point to this is how much, or in which path it is more, or in which path it is less. So there you can easily use the properties of the conservative force there. Similarly for non-conservative force. But if any expression for force is given, and there you have to find work done, first of all you will have to decide whether it is your conservative or non-conservative. Then only you can find the work done. Because if it is conservative, then it will depend only on initial and final position. If it is your non-conservative, in that case it will also depend upon the path along which it is carried out. Or first, if you have to distinguish, how will you conclude that this is a conservative force expression and this is a non-conservative force expression? Let's just discuss there the mathematical expression for. Of course, you will not be asked to derive that one, but at least you will be able to understand when we say that this is the way how we distinguish between the conservative and non-conservative, or decide whether a particular expression for force is conservative or non-conservative. You should know that how we have got this expression. For conservative force, there is one expression, curl F. This should be 0. Now, what is this? This is basically your I dx j Of course, when you will go to the higher class there, you will know that this is your operator, and there if you take its dot product there, in that case it is called as the divergence of that function. If it is taken the cross product, then it is called as the curl of that function. Like here we call it as the curl F, because we are taking the cross product. And for force we can write it as your Fxi, Fyj, Fzk. This is 0, right? This is your partial derivative. Okay, not the normal one. That means when you are doing the partial derivative, what will do, whatever variable you are taking with respect to which you are differentiating, other than that, whatever terms are there, you will treat them as constant. Like if suppose you have the expression of x square y. If I want its partial derivative with respect to x, we'll treat this y as constant and will differentiate only x square. So it is not the normal derivation which you are doing it partially. So there you will take this one, like if it is this particular term and it is partially differentiated with respect to x, then we can write it as y as a constant and differential of your x square, that is your 2x. But same term, if x square y is there and we are taking its partial derivative with respect to y, in that case now x square will take constant and will differentiate y. So differential of y with respect to itself will be 1, so it will be your x square. This is how we will be using it or differentiating it partially. Now this expression, if you take, this is what? This is your cross product of two vectors. So how we write that? I, j, k. It will be the expansion of the determinant. So this is your d upon dx dz. This is your fx, fy, fz. It is this particular determinant, and this one is 0, so we'll write it as 0. You expand that. So what will happen? Like for I, if I'm expanding, in that case it is your d2fz dy minus dfy dz I cap plus, it will be just opposite order we are using. So del fx dz minus j, and the last one for k, if you take, it will be your del f y del x minus del fx del y. This is k 0. This will be the normal expansion of the determinant there for the cross product of the vectors. Now if this is 0, then individually all will be 0, and individually if this is 0, that means this term will be 0, this will be 0, this will be 0. So what you will get here, from this one if I take, we will get del fz del y equals to del fy del z. This is 1. From this, fz del x, these should be equal. And third one, okay, all should be equal, means you will get 3 cases there, and you will have to see whether that derivative, that is the partial derivative, is equal or not. If it is equal, then it is conservative, because for conservative force we have curl F0. So you will see that whether these partial derivatives are equal or not. If they are equal, then it is conservative force. Now to remember this one, you just see here, you are taking del Fz, you are differentiating it with y. Here it is just the opposite. It is your y, here it is your del Fy, and this is your, with respect to z, you have to differentiate. Here it is your Fx, you are differentiating with z, partially of course, and here it will be Fz, you will differentiate with x. Fy, you will differentiate with x, and Fx, you will differentiate with respect to y. All will be the partial derivatives there. Now let's see how we'll use that one to the different problems there. Suppose this is the expression for the force. It is given as your 3xi cap plus 3yj cap. You have to see whether this expression of force is conservative force or non-conservative. So here you can see this force expression is basically in the form fxi fyj. Z term is not there. So in that case, we can just take it as 0. So here, again, if you go, this is your del fx by del y. If you consider this, how much it is? It is the differential of 3x with respect to y. Remember, we are differentiating with respect to y. This is the partial derivative. So these terms will be taken constant here. So in that case, this will be 0. Whereas if you take del fy and differentiate it with x, so it is your 3y with respect to x. Again, this is 0. So this term is 0. Let's take for the other pair. So that means what we have got? Del fx by del y, same as del fy del x. We have got these two equal. Now let's take the another one. Del fy del z. Let's see that whether they are equal or not. Here del fy was how much? 3y. You are differentiating with respect to z, and this term was your 0, fz. So 3x partial derivative with z, 0, this is 0. So this is also equal. Similarly, we can show it for x and z term there. Like you can show it for del fx del z, whether it is equal to z del x or not. This is your 3x by z, and this is your 0, because it is a differential of fz, which is 0, and this term is also 0, so it is equal. So all the three pairs which we have taken, they are equal, so it is a conservative force. So this f is your conservative. So this is how you can find. Let's take another example. This time it is given f is equals to 3y I cap plus 4x j cap. You have to see whether this is the expression for conservative force or non-conservative force. So again, here if you consider, this is your Fxi, Fyj and Fzk. So let's take now del Fx, del y, yx. Now in place of this Fx, how much it is? 3y. And you are differentiating it with respect to y. Fy, it is your 4x. You are differentiating with respect to x. So now here what you will get? This will be your 3. Here it is your 4. This is not equal. So that means this is non-conservative. No need to go further. Because one pair, if it is not equal, definitely the other pairs we need not check that. Because all the 3 pairs which we have taken, they all must be individually equal. What we have seen in the expression. So in that case, this is an expression for non-conservative force. Let's take, this is another question. It is given that F is x square I cap plus y j cap. This acts on a particle and it moves it from point A having coordinate 0a to B. That is, it is moving it from A to B having coordinate AB, then to C, B0, and then to D and back to A. So that means if you just plot this one, how will you get that? This is suppose point A having coordinate 0a. This is the B having coordinate AB. This is your C, B0, and this is your D, 0, 0. So that means it is moved like this, and you have to find what is the work done in this case. So first of all, let's see before we do the expression and derive it there, because it is showing it is a variable there, x and y, all terms are there. First of all, let's check before we find out and proceed to find work done. What type of force this one? So if it is there, we can write F as your, again the same way, Fx I Fyj plus 0. That is for k. So del Fx del y, and we'll check it that whether your del Fy by del x equal or not. So it is your del x square coming in place of x, Fx, this is y, del y with respect to x you are differentiating. This term will be 0, x square differential with respect to y, and y differential with respect to x is also 0. So this is equal. Then del Fy, del z, del Fz, del y. Now Fy was your y with respect to z, and this is your 0, Fz. So in that case, this is also 0, and here it is 0. So this is also true. Now del Fx, del z, let's check it for Fz del x. This is your x square. This is 0, and this is also 0. So now what we have got that these are equal, this is equal, this is also equal. Means this is a conservative force. And if it is a conservative force, we know that work done by a conservative force in a closed path is 0. Here also it has moved from A to B, B to C, C to D, and then D to A. So it is a closed path. The point from where it has started, it has come back to same point. It is a conservative force. So work done will be 0. That is the total work done. You can say total work done in the closed path will be 0. So in this case, you need not find what is the work done in this displacement A to B, B to C, C to D, D to A. First, find out whether it is conservative or non-conservative. If it is conservative, then work done depends upon only initial and final positions. And also in a closed path, it is 0. It is a closed path, so work done will be 0. Let's take next question. If F is equals to x square I cap plus y square j cap acts on a body and it displaces it from point A having coordinate 1, 2 to point B having coordinate 3, 4. What is the work done in it? So you have to find the work done in this case. So here again we'll start with checking it whether it is conservative or non-conservative. So here in this case, if you consider that f, which we have written as usual, fxi plus fyj plus 0 for the k. Now del fx del y and del fy del x. This is your x square differential with respect to y. This is y square differential with respect to x. So it is 0. This is also 0. Let's now take del fy del z del fz del y. So this fy, it is your y square, and we are differentiating it with respect to z. This is 0. So this is 0, this is also 0, because you are differentiating y square with respect to z partially. So in that case, it will be 0. Let's take for the third one, del fx del z del fz del x. So again here it will be differential of x square with respect to z, and this is 0. So this is also 0, 0. That means this 0, 0 is correct. This is also correct here. And this is also equal. So that means this force is a conservative force. So this is your conservative force. Now we have to find work done for displacing the particle from point A to B. Remember, this is not a closed path. These are two distinct points there. One is, say, it is your 1, 2, and the other is there at 3, 4. So this is your A, this is your B. So in this case, you will have to find what is the work done in this case. So again, for finding the work done, it will be integral dw. Why? Because this is a variable term. It's not a constant that we can directly take force and dot product. We take it with respect to the displacement there. So this will be basically dot product. So it is your f dot ds vector. What is this f? This f we know that it is your fxi fyj. We are taking only two terms because it is only two given there. So it will be this term. And now for ds vector. Displacement, we know that it is suppose written as xi plus yj. So ds vector will be how much? It will be dx I cap dyj cap. So if you substitute it here, it is your dx I cap dyj cap. It is the dot product, and then it is your integration. Now here, this one will give you how much? Because I dot I will be 1. So it is your fx dx integral. Fx dy j dot I dot j, that will be 0. J dot I will be 0. So it will be only fy dy integral in the other case, as I dot I same as j dot j, that is 1, and I dot j, j dot k, all will be 0. Now you know how much is your x square, how much is fx, how much is your fy. Then you have to put the limits there. So this is your fx is your x square. This is your fy, that is your y square. Now the limit. Point was given as your 1, 2, B was having coordinate 3, 4. Here it is your integral dx. So that means what is the variation in the coordinate of x? It is 1 to 3. Similarly, for dy, it is the variation from 2 to 4. So now you just integrate and put the limit. X square dx is your x cubed by 3. Limit will be 1 to 3. Y square integral, there will be your y cubed by 3. Limit is your 2. So you have here x cubed by 3, limit is your 1 to 3, and this is your 4 cube, limit is your 2 to 4. So it will be this is the expression, because here it is your x cubed by 3, limit 1 to 3, and y cubed by 3, limit 2 to 4. Just substitute the limit. It is your 3 cube minus 1, whole term divided by 3. Here also it is 1 by 3. 4 cube minus 2 cube. So how much will be this term? This is your 1 by 3, 27 minus 1, that is 26. And this is again 1 by 3. This is your 64 minus 8. So that is your 1 by 3. This is 26 plus 56. And that is your, this is your 82 by 3. That will be the answer. This is the next question. If f is equals to y square I cap plus x square j cap, and this is acting on a body and displacing a body from point A 1 2 to point B, that is 3 4. This is suppose your point A having coordinate 1 2. This is suppose point B having coordinate 3 4. You have to find what is the work done, and it is also given y is equals to 2x. So let's see first of all whether this force is conservative or non-conservative. So for this one, again in the same way, this is written as your fxi fyj 0. This is your f del f x del y fy del x. So it is your fx, which is your y square, and this is your with respect to y, and here it is your CL x square with respect to x. So how much it will be? This will be your 2y, and this is your 2x. So what you are getting, 2y equals to 2x. These are not equal. It means this is not the expression for a conservative force. This is a non-conservative force. So we'll have to find out work done for this case for the non-conservative force. Points are given that it is displaced from point A to point B. Coordinates are given. Work done formula will be same whether it is your conservative or non-conservative. It will be force and displacement dot product there. Now, why this additional information is given? Y is equals to 2x. Here, because if we have to find work done between points A and B, so work done between this can be carried out if we have displaced the body from A to B along this path. This will be the work done, and we can find the work done. But from point A to point B, I can also go by some other path like this. Or it may be that we go it like this. If it is non-conservative, then it will definitely depend upon the path. Had it been conservative, then it will only depend upon initial and final position. But this time, as it depends upon the path, we must specify along which path this work has been carried out. For that, this is the additional information given in the problem, that y is equals to 2x. You have to move the body along this particular path. So for that, now if you use this one, work done, it will be integral dw. So this is your fx I cap fy j cap dot dx I cap dy j cap, and it is the integral of this. We have already done in the last problem. Fx dx integral plus fy dy integral. Here, this is your x square, fx, which is given as your y square, fy, which is your x square dy integral. We have to use this also. So y is equals to 2x. So what we'll do here, as it is y square equals to 2x, so we'll substitute it as 2x whole square for y into dx, and we'll integrate it. Similarly, for this one, it is your x square. So x will be how much? It is y by 2 whole square dy, and we'll integrate it, so that we can define the specific path along which this work has been carried out. So now if you use this one, of course we have to put the limit also. For x it is variation from 1 to 3, and for y it is variation from 2 to 4. So this one will be equals to 4x cubed by 3. It is 1, 2, 3. It is your 1 by 4 because it is your y by 2 whole square term there, and it is your y square dy integral is your y cubed by 3. It is your 2 to 4. Now if you just put the limits there, then it is your 4 by 3. This is your 3 cube minus 1 cube for first term. This is your 9 and this 3, and this is your 4. So it is your 12. This is your 4 cube minus 2 cube. So this is your 4 by 3. 9 minus 1, that is 27 minus 1, that is your 26. 1 by 12, and it is your 64 minus 8, so it is your 56. So you can simplify this one. This will be your 12, and this is your 4 into 3 into 26. 312 plus 56 by 12, that is 368 by 12. You can cancel out the term. This will be the answer there. So this is how we do the problems with conservative and non-conservative forces, especially if you have to find the work done, or you have to distinguish or find out whether the given expression for force is conservative or non-conservative.